Okay, so this video, we're converting equations. So we have the same setup, because this is how a rectangular coordinate x comma y relates to a polar coordinate r comma theta. Okay, so we're using this stuff primarily right here. Let's highlight that. This is the stuff that we are going to be using today. Okay, and it's all about substitution. So we are looking to replace. We're looking to replace things. Well, that's the question. What are we trying to replace? Well, if we're going from a rectangular or a polar to a rectangular, we're trying to replace r squared. Okay? If you ever see an r squared in your equation, then we're going to replace that with x squared plus y squared. Okay? If you ever see a r sine, if you see this, if you see r sine, you can replace r sine with y. And if you ever see r cosine, you can replace r cosine with x. So our job here is to replace your r's and your thetas with something in x's and y's. Okay, so we're trying to turn a polar equation, which you probably have no idea what a polar equation looks like at the moment. And that's okay. Well, it's really not okay. It makes it easier if you know what they look like. But we can still do it even though you don't know what they look like. Turn them into like lines and quadratics and ellipses and circles and other conics that you probably don't know what those look like either. Well, anyway, let's see if we can do this with our limited knowledge of graphs. So these are all polar equations. How do we know they're polar equations? Well, they say r equals, first of all, r stands for radius. So anytime we have an r or perhaps an r and a theta in your equation, that's how you know that you have a polar equation to begin with. Okay, so let's talk about this. This says that the radius of your graph equals 2. That's what we are being told here in our very first problem. Radius equals 2. So, what type of a graph, what type of a picture has a radius of 2? So this is a circle. Okay, so it says the radius is 2, so the graph of this would be a circle centered at the origin, with a radius of 2. So we're going to try and write the x comma y, right? The equation for a circle centered at the origin with a radius of 2. Okay, so I have r equals 2. So let's look back up here. Can I make that into r sine? Can I make it into r cosine? Or should I make that into r squared? Which one do you want to do? Well, and here's where knowing what it looks like comes in, because this is the circle part of an equation for a rectangular equation. So what we're going to want to do is we're going to want to change r into an r squared. And how can we mathematically change r into r squared?
X squared plus y squared.
Well, one way is to multiply both sides by r. Okay, will that give us an r squared?
Yes.
Sure will. R squared equals 2r. Once again, so that's okay because now we can replace r squared, but then we have another r in your equation. Okay, so maybe multiplying both sides by r isn't the way to go. What's another way we can change r into r squared? We could square both sides. Right? As long as we do the algebra, right, the operation to both sides, we are being mathematically legal. So r squared equals 4. Right? Mathematically, that's the same thing as r equals 2. So now I can say, oh, I know r squared. R squared is a replaceable polar function, right? So we're going to now replace r squared. And what do we replace r squared with? X squared plus y squared. Okay, so I have created something, right? I have created a term that is replaceable. r squared is something that can be replaced. And whether you know it or not, this is your rectangular equation for a circle centered at the origin with a radius of 2. Okay? Which means we're done with the problem. X squared plus y squared equals 4. That is your answer. So let's look at our second one here. R equals 4 times the cosecant of theta. R equals 4 cosecant. So cosecant is not one of our things, right? We have cosine and we have sine and we have tan. So thinking about your trigs, which trig does cosecant relate to the most? Cosecant relates to sine. The cosecant is the reciprocal of the sine. Okay? So cosecant is not one of our replaceable things, but sine is. So our first thing is to use our identity and replace cosecant with 1 over sine. So in other words, 4 over sine. Okay, so we're replacing cosecant. Cosecant is not one of your relationships, but sine is. So we replace cosecant with 1 over sine. So in other words, 4 over sine. Okay? Now, it would be really nice, right, if the r and the sine were together. Because if r and sine are together, I can replace r and sine with the letter y, right? And that's my rectangular. So is there a way that I can get r and sine together? Yes. Multiply both sides by sine. Okay? To get rid of your denominator, we multiply. Now, I know over here it says sine times r, but I'm just going to write it in this order because multiplication is commutative. So sine of the angle times r is the same as r times the sine of the angle. Well, that's wonderful because now I have created something that I can replace. What can I replace r sine theta with? I can replace it with y. So this is the equation of y equals 4. Okay, so what type of an algebraic graph is y equal 4? That's a horizontal line that crosses your y-axis at positive 4. In other words, this is an equation in polar form of a horizontal line, right? That is completely disguised. You probably would never have guessed that, which is okay, which is why we can do these things. Maybe, maybe. Okay, so number 3 has a similar process to it. R equals 11 secant of theta. Okay, so secant is not one of our replacements, but what trig does secant relate to? Secant relates to the cosine. Secant is 1 over cosine, but not 1 over cosine because we have an 11. So we replace secant with 1 over cosine, right? That is the identity. 11 over cosine equals r. Okay, so now we do those same steps. To move cosine to this side, we're going to multiply both sides by cosine. So r times cosine equals 11. And now I have something that I can replace. What can I replace r cosine with?
X.
I can replace it with x. So this is an equation x equals 11, which is a vertical line through x equals 11. Okay, so this up here, this is a polar equation of a vertical line, right? We never would have guessed that looking at it. So the strategies are basically the same, right? If you see something, we want to create our sine, we want to create our cosine, we want to create r squared if possible, because those things can be replaced. Okay? So here is another problem. We have r equals 4 times the cosine of theta. R equals 4 times cosine. So is there a way we can move this r over to here? We can, but that's through division, right? And cosine over r, that's not a thing. So how can we create something that can be replaced?
You can do 1 over secant and then multiply by secant and then change it back.
That's very interesting. The easy way is to multiply both sides by r. Okay? If you want to have r times the cosine, then make it r times the cosine. So we're going to multiply both sides by r, because what you do to one side, you have to do to the other side. So on the left side, what is r times r? That's r squared. Ooh, that's also a replaceable thing. Equals 4 times r cosine theta. Remember, multiplication is commutative, so you can put this r anywhere you want it. It can go in front of the 4, it can go in between the 4 and the cosine, and it makes the most sense to put it here, because now what can I replace? I can replace r squared with x squared plus y squared, right? So no longer do I have an r on the left side, and I can replace r cosine theta with x. So I have the equation x squared plus y squared equals 4x. Okay, now that's a pretty okay equation. That's an okay answer. Sometimes you can be done right there. Okay, but thinking about the graph, what type of a graph does an x squared plus y squared always give you? What did it give us in number 1?
A circle.
A circle. So any equation with x squared plus y squared in it is a circled equation, right? But because it equals 4x, that means the center is not at the origin. Okay, is not at the origin. So we could do some fancy things called completing the square, and we can figure out exactly where that is going to be. Okay, but I think we'll do that at a later date. We don't have to worry about that now. At least not on this video. So we can leave it like that, but know that this is a circle with a center not at the origin. Circle, C-I-R-C-L-E. Circle with non-origin center. Okay, so we'll talk about graphing these things next week and where we actually graph them. So this is a circle with a non-origin center. Okay, so similar thing here with number 5. Okay, so multiply both sides by r. That gives r squared equals -8 times r sine of theta. Remember, we write it like this because we want to replace r sine theta. So we replace r squared with x squared plus y squared. And we replace r sine theta with y. Okay? So once again, this is a circle with a center not at the origin. Circle with the center not at the origin. Okay, so let's go the other way. Convert each rectangular equation into polar. So if we have x, we can replace x with r cosine theta. If we have y, we can replace that with r sine theta. Okay? And if we have theta, then we're going to do some other things. Okay, so x squared equals 16. That's really close. So how can I get that to be x equals? I can take the square root of both sides, right? That is the operation that we can do to both of them. So I have x equals 4. This is a vertical line that goes through 4 units to the right of the y-axis. Okay, wonderful. Now I have x by itself. I can replace x with r cosine theta. Now my equation doesn't have an x anymore, it has r's and thetas. So my last thing is to solve for r. Solve this equation for r. How would I go about solving for r? Divide by cosine. So we did something similar to this up above, or we undid something similar to this up above. And then to simplify, what is 4 over the cosine? Simplify to 4 times the secant. 4 times the secant. Okay, so this is the opposite from what we did up above, right, on the other example, where we were given a polar and we wrote it as a rectangular. Okay, so we try not to have fractions if we can possibly help it. Sometimes we can't help it. Okay, number 8, what things can we replace? X, we can replace x, and we can replace y. So we replace x with r cosine theta, and we replace y with r sine theta. So this one is a straight replacement. We don't have to do any prior manipulation. We have an x and a y, so you just straight replace them. Okay? But now our business is to solve for r. And I see r in 2 different places. That's too many r's. So how can I take these 2 r's and make them into just 1 r?
R squared.
You want to square both sides? Well, that's going to be really complicated. No. How do we take 2 things, 2 letters from 2 different equations and change it into 1 letter?
How do you do that?
F actor. Factor. We're going to factor it. Okay? This is called a common factor. What do 4r cosine and 5r sine have in common? They have an r in common. So I'm going to common factor out the r. So this leaves me with 4 cosine theta minus 5 sine theta when I common factor out that r. Okay, so if we ever have multiple equations with the same letter, you can factor that same letter out of every equation. So it's r times all that stuff. And now if we solve for r, what's our next step? Divide by all this stuff, right? We're going to divide by 4 cosine theta minus 5 sine theta. It's okay. We're dividing by one thing. 3 divided by 4 cosine theta minus 5 sine theta. Okay, now it's pretty complicated in order to change this into secant and cosecant, so we're not going to do that. We're just going to leave it with an r here and a cosine and a sine there. Okay, because doing that is some major mathematical manipulation, which is not what I want to test at this time. Okay, so try the last one. It's done very similarly. X squared, oh no, it's not done similarly. This one is done ridiculously easy. X squared plus y squared equals 10. What can we replace?
R cos theta squared.
X squared plus y squared. We could do r cosine squared. That's a lot of stuff. Let's just replace x squared plus y squared with r squared, right? That's the easiest, most direct, simplest substitution to do in this case. Okay, yes, you could have replaced x with r cosine, then you would have had to square that. Same thing with y cosine. It would have been a lot of work to do. So we're just going to do this. And to solve for r, our last step would be to square root both sides. So this is an equation of a circle with a radius of square root of 10. Okay? So I think that I have seen with, as you become more practiced with these, they will become easier. right? You want to create things that you can replace. You create it by doing something to both sides. Squaring, multiplying by r, replacing, things of that nature. Okay, so this is how we do conversions of equations from rectangular to polar.